Thing that people still ask me on a daily basis is what exactly can I utilize AI for? What is its use cases outside of just like putting it into things and like selling AI, etc. And so let's break that down very simplistically. To me, it's anything that you can think of and use it for. And then so in this example, I'm going to utilize a scientific concept, this concept of redox reductions, which I just learned about today. And we're going to turn this concept of redox reductions into an experiment that will showcase and optimize for stock market trading. So we'll take it into a real world example, right? We're going to take this concept, we're going to utilize AI and code to teach ourselves about this concept and how it works and understand it fully. And then we're going to totally reimagine that concept by taking the patterns of that concept and just the patterns and then putting it into a real world application in a real world use case. And so when people ask me what can you do with AI, what exactly does AI do, it opens up doors like this. I would have never been able to create a project like this in a million years without AI flat out. So with that being said, let's dive into this. So this is called digital redox reactions. And if you're not familiar with what redox reactions are, you're not alone. And they're a very recently discovered concept, which is, so I'm just reading about this concept and I discovered it. It's a type of chemical reaction in which the oxidation states of the reactions change. And oxidation is the loss of electrons or an increase in the oxidation state, while reduction is the gain of electrons or a decrease in the oxidation state. If we look at it very simplistically, here's a diagram, right? So you have when this code runs, and then this is what the function does, right? So you have electrons, and then like in this instance, we have water electrons, and then they're passing to the sodium and the nitrate electrons, the nitrate modules, and then they're passing their electrons. And then so what this redox reaction does is it's the gate for electricity. So we've known that electricity flows through these objects and that they can pass energy between them, right? Like this water molecule can pass energy to the chloride molecule, and then the chloride molecule can pass energy to the nitrate molecule, and then if you combine all those, you get sodium nitrate, right? And then so how exactly does that process work? Does that energy transfer work? And then the switch in the energy transfer is this redox reactions. And then, so that's what we're doing. That's what we're just building out here, right? And then, so our first code here is exactly just this process. It's an oxidation process, and then there's the passing and then a reduction of energy that goes through, and then they pass the energy back and forth, and then via mathematical equations, we have sodium, chlorine, and water. I was calling it nitrogen, sorry, sodium, chlorine, and water. And then there we go. And then we run through our experimentation. And then within this, taking this a step further, right? So this is what it actually looks like, and what this process is, right? Okay, so now I understand, I can get a firm understanding of what redox reactions look like. I actually understand them. I understand what this chemical composition is and what it's doing, right? These molecules are passing energy to each other, and it's a gated energy process, and they share energy essentially. And then, so, okay, cool. So what does that look like in digital form? To me, in digital form, it looks like something like this. And then, so I've got agent A, agent B, and agent C, and then they share energy between each other, right? And then so that goes through. And then so if we take this concept, we put it into a digital agent form where I want like for agents to go through and navigate in an environment, we get this. So starting off, understanding the scientific concept, bringing it into the digital realm. What would this look like if I made agents out of this? And then so okay, like now let's make our agents solve actual optimization problems. And then so the first one that we're going to solve is actually this one. I need to bring up the writing here. It should be like this. There we go. This one should be like so. Awesome. So in this one, what we're doing is we're creating nodes that represent servers in a cloud network, and then each one of these nodes it has a workload and a capacity, and then the initial workloads are going to be assigned randomly, and then what we're going to do is utilize this same exact natural process for workload balancing of these nodes within this network, right? And then so these nodes are going to be exceeding their overload threshold, and then we need to transfer that overload to all the different nodes in order for load balancing to occur, right? So it's simulating load balancing within a network. Very straightforward is what we're doing within this, and then and this is not the right one. Need to fix the direction of this code, but so this is the code block that we want to look at. This is our load balancing code block, right? And then so I'll move this one up. One more. That's where I want this guy. And then so now we have our load balancing network that we're looking at here. And then what we can see is that some of these got up, like so this one is still at 100, this one's at 95, 94, 94, but it's balancing out, right? And then so this algorithm isn't going to find the optimal balancing, but it's going to balance always below 100, right? That's its goal. It will never let it exceed 100 on any of these nodes. And then so whatever it needs to do in order to do that, and that's what this algorithm accomplishes. And then this algorithm accomplishes this very straightforward, right? So then again, I'm utilizing this natural concept. So this natural concept that we just learned at the top of the video, like why did I go over that scientific concept in this concept of redox? Because like every element of redox, like what that energy transfer, what it's doing, the mechanics of that energy transfer process is alive in this. We just took the patterns of it, right? And then so how do I get that, and how do I get from that redox process to this? I utilize AI to help me code out, right? Flat out. And then so that's what I'm trying to demonstrate within this. Like, what's a real world use case? Here you go. Like I can not only teach myself this scientific concept of redox and actually understand it, and then actually utilize AI to help me understand it, to build out code to understand it, to walk through, okay, I actually understand what's going on here. I can visualize this concept and then very clearly understand exactly how this redox process is occurring and what exactly is occurring within there. It satisfies my curiosity mind. And then let's say it's in the next level, right? Like real world application. And then so boom, here we go. First example that I can think of is load balancing. But then let's take it even more real world, right? Because like people would want to take it a step further than this. Like maybe that's not practical for everyone. Let's say that I want to make it a stock market trading algorithm. Flat out, right? And then so in this particular instance, I do the same exact thing where I create this stock market simulation in this instance, and then I create essentially I'm utilizing these same scientific processes that are occurring within the energy transfer, right? So then in the energy transfer, I am utilizing and to simulate loss of resources within this environment, and that occurring, and then what happens, and the transfer back and forth, and the random aspects of that, all of the patterns of this redox reduction, we've created it into a digital format, and then now we're at this point where we're utilizing adjust stock price functions, simulate stock market, etc. And then all of these functions are utilizing those concepts of redox reactions, and they're utilizing the patterns of it, right? And then again, like, I mean, to get to this level and this type of concept, was doing this, right? I'm definitely utilizing AI to help me and to assist me get to this point. And then here we are. And then we look at this final result of what our algorithm does, and what it is, and how it works. And then we see here, it's our stock market trader, right? So we've got stock market traders A, B, and C. And then in this instance, they all balance out, which is good. So they all end up with almost the same amount of money. And then in this instance, C gets clobbered. Look at this. C is getting absolutely clobbered, but it has all of the stock. But what I'm assuming is that the stock price is absolutely worthless. Yep, stock price is at $66. It started at $95, and every player started with like a whole bunch of money. C started with a whole bunch of money, and then so B took all the cash. B took A took a lot of cash and stocks, and then C just like shot for the ceiling. And then currently in this simulation owns all the stock in this world, 18 shares out of 23 total shares, but it has no cash. So kind of gives you like a real like this is a real world dynamics that would play out, and exactly what would occur in these types of situations, right? And so you get to play around with this, and these like this shape changes a lot within this, right? So you can see like this is dramatically changing in shape, and then so in this instance, buyer A gets creamed, and buyer A seems to be in pretty bad shape. Whereas trader C in this instance is making a killing. It's got a lot of cash and a lot of stock. So you see the simulation comes out different every time, and then we're literally utilizing these concepts, concepts from nature, this concept of redox, which deals with oxygen, oxidization, atom transfer, and electron transfer. And then we take that concept, we turn it into digital agents that operate within the environment. We experiment with it, and then we can come up with other sort of real world use cases. And then we come up with the ultimate use case that we actually want to do within this, which is a stock market trading simulation that works out pretty well. And then again, all of the mechanics of it are operating purely based off of this redox process. And then so to me, pretty cool. I get to learn scientific things, and then I get to apply them to real world concepts. And then so to me, I don't ask the question of what exactly does AI do, because it does things like this. And then so if you like this type of content, please like and subscribe. Thank you very much.